Hello everyone. In the last video we talked about different server models like primary, secondary, or even load balancing the work to worker nodes itself. I have implemented both of these. We will talk today only about the primary, secondary, and in the next video we will talk about the load balancing stuff, else this video might get too big. Implemented are both of them already. If you go to the common server library, there are server models and we have implementations for everything there. Currently, we want to talk about primary secondary. Primary secondary is often known from databases. For example, SQL is a typical case where you have a primary and secondary database. What that means basically is that you write operations to the state are only done by the primary, but most SQL frameworks and everything support to read data from the secondary. This often comes with the downside that reading data from secondary could be not state-of-the-art data, so there could be new data on the primary that the secondary doesn't know. It depends on the framework and what you're using, if that's the case or not. There's, for example, if you're using Service Fabric, which is a microservice framework from Microsoft, they have the capabilities to read from secondary, and I think they had it in preview a long time ago. Don't know if it's in production already. They were thinking about implementing a read from secondary with a quorum check. So then you can only read from secondary when the quorum, so most of your services share the same state. So there are different models that exist out there. Some even make reading from secondary impossible, so that only the primary is the main state, and if you want to read from secondary, that's not possible. You get an exception. And when the primary dies, the secondary takes over. This is basically what we implemented here. So we have a primary secondary server. You can instantiate this server and let it work. Let me just show you when I run just a service, which is currently, for our case, it's the load balancing service. If you want to have it more detailed, then there is the possibility, just give me 1 second, there is the possibility to go back to a different commit, like this one, primary secondary server logic. This is where I implemented first primary secondary, and if you remember the last video, we had a singleton which handles our enemies and props and everything that is attackable by the player on the map. So we have this singleton per map, and the first thing I did was implement primary secondary logic on top of that, so that the singleton is not a singleton anymore. It has this primary secondary state. So you can go back and just witness the primary secondary stuff. Let me show you how this primary secondary works, and we start the service 1 time, and the service will detect there was a primary, but it's not trustworthy anymore because I restarted everything, and it will detect that and will put itself as a new primary. We will talk about that in a little bit more detail when we go through the code, how that works. So when I start multiple ones, let me start 2 more, then we will see that the other ones are not the primaries because we have a trustworthy primary who's working. So when I kill a secondary, nothing happens, no one cares about that. But when I kill, let's start another one, why not? So we have 2 secondaries again. When I start a primary, those 2 secondaries will detect that the primary is not trustworthy anymore, and then one of them will take over. this is based on a cooldown that is configurable. I think it's configured at 2 or 5 seconds currently. So after 2 or 5 seconds, whatever is configured, they will define, okay, this primary is not trustworthy anymore, I will take over the work. And the other one will detect, okay, another primary is there and he's trustworthy. So this is everything we do for primary secondary. There's a discussion I have with some of my colleagues if that is needed, because we will at the end deploy our service into Kubernetes. And in Kubernetes, if your services dies, Kubernetes will restart it. The problem with that is Kubernetes needs some time. So when a pod dies, Kubernetes will start another pod which will boot up your Docker service and everything. And this might take half a minute or a minute, depending on what your Docker container looks like. And just having a secondary around which can take over really fast is just a little bit faster. It's way over engineered because you don't need that. Kubernetes would handle that for you, but I think for educational purposes, this is a great thing to implement. And this way we don't need to rely on Kubernetes, so we can host it somewhere else if we want to. So I've killed another primary and this one will take over. So how does this work in code? First of all, we use a feature from Redis to define who will become the new primary. So I'm currently using from done the Redis for VS Code. Honestly, it doesn't matter which Redis thing you use. One important thing that I have to consider are the features they support from Redis. For example, this supports the string hash lists, set and C set and streams. And we will use these sets, lists, and hash and strings. So if the plugin supports those, this is great. So we have a database full of my tests. Let's just clean that. It's quite easy. You can do /db, and it should get rid of everything in the database. And let's just redo our test real fast to show you what the database will look like after we are done. So let's just start it 3 times. And maybe kill the primary one time and let one of them take over. And while one of them is taking over, we look at the database. So let's refresh that. First of all, these f start tone load, they are part of the distribution of the load to the worker node, so we ignore them for now for this video. We will look at them in the next video. What we care about is the heartbeat and the primary. So the primary says who is the primary. And the trick is Redis supports a feature where you can write a string or a hash or whatever to the database only if nothing exists. And what we do is each of our servers, when there's no primary, will try to write this primary value with their own ID. And it will fail for everyone except for one, and we let Redis decide who is the one. There are algorithms out there to do this without Redis or a higher instance deciding who was first. But those algorithms are very error prone and honestly quite hard to implement, and why should we do that when we could leverage the Redis for that, which is perfectly fine in my opinion. The algorithms just are often used in frameworks where they don't have a higher instance that can decide such a thing. But we have the Redis and we already pretty much bound with our game to the Redis, so why not use it? The algorithms work like that they communicate with each of their neighbors that they want to be the primary, and since the best connection will reach the most neighbors as fast as possible, and the one who reached the most of the neighbors as fast as possible will be the primary, with broadcasting messages around, and that it's quite complicated for just deciding who's the primary, while when you see the implementation we do with the Redis, it's way more error prone than using the Redis. On the other side, we are currently then bound to the Redis, but other databases like Cosmos DB and everything also support this feature, so we could go to another instance of or we could even ask a zookeeper or something like that for this kind of thing. So there are a lot of options out there to really make it simple, and since your backend for your multiplayer game most likely will become complicated really fast, keep it stupid simple is a really good concept to follow. So every instance writes its own heartbeat to the database. They write it to the database every 100 milliseconds. So every update cycle, they write their heartbeat to the database. And then everyone looks at the primary and sees this ID, and with this ID it can look up the heartbeat. And if the heartbeat is too long ago, for example 2 seconds, depending on what we configured, then it will say, okay, this instance is not trustworthy anymore, and it will force delete this entry. We can trigger that by hand now. I can force delete this entry. We deleted the key and another one took over. So the whole thing behind it is when we delete the key, another one will take over and will find out that there's no primary. So in code, this is really not that complicated because of the Redis. We have 2 repositories. One is for the heartbeat and one is for the primary. And then when you instance the service, we have a prefix, which in our case is the map name, for example. It's E star and the map name. So they don't collide with each other when we have multiple maps on, because each map will get one of those load balancer services. And then we have some configuration like update, how often does the update run, 100 milliseconds, and how long does it take till we don't trust the primary anymore. And then we feed that into the repositories, and like I said, every update cycle we write the heartbeat to the database, and then we do our update primary logic, and after that we call our on primary update. This is some inherent, so this inherents from server, and the server will do the delay thing. So it will delay the update loop. It will measure how long it took, and then it will delay it so that the 100 milliseconds are applied. So if your update loop takes 10 milliseconds, then it will just wait 90 milliseconds and things like that. And also it will write to the database if that is wanted. It will say for you how long the update duration took, which in the load balancer part we will talk about that a little bit. But for the primary one, it's not that important. For the primary one, the only important thing is we write the update, and then it will call your function. So when we look into very deep into the service, how it's implemented. It's just, we get a load balancer service with the thing we want to distribute. And the load balancer service is basically our logic. We will talk about this load balancer in the next video. Like I said, I know I repeat myself, but the load balancer service just gives the primary secondary thing an update function. That's all it does. So when you want to use this primary secondary server, then you have to give it an update function, and you can do your logic in there, and you will be sure that only one of those instances will run, even though you can spawn multiple of those. On the other side, this also means that your update function need to be able to take over the work. So when no instance A is dying and instance B takes over, then it would be great if instance B really can take over the work from instance A and not, for example, respawn every enemies. Depending on your game and what you're doing, this is fine. It would be easier to just respawn every enemies, and that's what I implemented at the start, but currently even the enemy state is preserved. So, like I said, every update, it writes its own heartbeat. Writing the own heartbeat is just writing the current date time UTC now ticks. So it's the current date time. What date and what time is it? It just writes it to the Redis database with the key. The keys, what we saw, the prefix, which is including the ID, which looks like that. It's E star town underscore, E star town is the prefix, then we got underscore heartbeat underscore and then the ID. And this is what get ID does. It takes this string and adds its own ID at the end of it. And we write that heartbeat with that ID. The other thing we could call in this repository is check if the heartbeat of a given ID is fine. And what this does is it gets the heartbeat. It will check if it's in there, so we have some null checks and we have some parsing error checks. If one of those will happen, then it's not trustworthy. So having no data or false data makes this heartbeat not okay. And then we check how long is the heartbeat ago. So we read the heartbeat ticks into a date time and we compare that with date time UTC now, and then we got how long is the heartbeat ago. And if the heartbeat is longer ago than what we trust the primary, this heartbeat is not okay. And if this heartbeat is shorter back in time than how long we trust in our delay, then this heartbeat is fine. And in our server logic, what we do with update primary is we get the current primary, which is basically getting the ID out of this value, the eTown primary. So we read the data. Let's just skim over that. It's really easy. It's a fixed key value and we just read it and then we get the primary. If there is no primary, then we will start the race. So we will try to set ourselves as the primary. How do we set ourselves as the primary? There is a feature, like I said. We try to write the key, which is basically this primary key again, with our own ID as a value. But there's a little feature that we use and it's when not exists. So this doesn't overwrite the primary, which also would work, but it's kind of dirty because you have primary switching really fast depending on what happens. So this will make sure if the value exists, it's not overwritten. So the first one, the fastest one will become the primary basically. So this way a new primary is elected and in the next cycle the primary is here. So if there is a primary, we check if we are the primary ourselves. And if that's not the case, so only the secondaries are checking if the primary heartbeat is fine. And if the primary heartbeat is not fine, they will force delete the primary out of the value. So we will basically delete the key like I did here with del key. We will delete it, and then we can again set the value with the next update cycle. The primary will be empty and we will start the race, and we try to set ourselves when it not exists. And since we forcefully deleted it, it doesn't exist, so a new one will become the primary and will in the next update cycle go into its primary and find out itself that he is a primary. So I think there are some cases where you want to initialize something when you are the primary. So I added another function which is on primary start, which I don't use anymore, but I leave it in. There might be some cases where you want to lose that. So if you weren't the primary last update cycle and you just become the primary, this is what this check does. Then we can call this function if you put something into this action is called. So on primary start, and then we will save if we were the last primary or not. Yeah, this is everything about that. This is how this works. Basically quite easy. We write the heartbeat to the database. If the heartbeat is fine of the primary, then we do nothing as a secondary and the primary is running its update loop. And if the primary is not trustworthy anymore because he didn't write the heartbeat fast enough to the database, then we will forcefully remove the primary from its state, and then a race will start again. Who writes first to the Redis database that he is the primary will become the primary. And that's everything I have for this video. I wish you all a great weekend, and next week we will talk about how we load balance every enemy in our MMORPG in the future with the AI logic and everything behind that. I want to thank you, my Patreon Julian, for supporting this project. I wish you all a great week. Bye.